Okay, folks, so now that you know what a NAND gate is, let's just jump to the assignment. You can read this, and it's going to explain about what I'm going to tell you, so I'm going to say it in my own words. So you're going to design something, and you're going to have 4 inputs, A, B, C, and D, and what they are is they're voting booths. So these are a booth that you would go into to go vote. And this company wants you to design a circuit. And this one, for the first time in this class, we're going to have 2 outputs, but 4 inputs. And this is pretty much the design they want. So these are the 4 inputs, the 2 outputs, and here's the rule. They want this booth is going to be a light, and it's going to turn on if there's a booth available. This alarm light will turn on if a rule is broken. And the rule is pretty simple. The only rule really is that you just can't, 2 people just can't vote next to each other. So if somebody's voting in booth A, you cannot vote in booth B. If somebody's voting here in booth B, nobody can be in A or C. They would have to be over here in D. And, if they're in booth D, nobody can be in C, and so on and so forth. So the rule is 2 people cannot vote next to each other, okay? That's it. So once again, 4 inputs. These are just booths. There'll be a 1 when there's somebody in the booth, a 0 when nobody's in it. And the booth right here will turn on, this light will turn on if a booth is available. So if nobody's in them, of course that light will be on. If somebody breaks the rule, the rule that says 2 people can't vote next to each other, then the alarm light will go on, all right? So know that. We need to know that. So when you build the truth table, you would just do 4 inputs, A, B, C, D, and then of course 0, 1, 0, 1, 0, 1, and the pattern until you get all the way down and you have all these. And on the far left side, you have the 8 zeros, the 8 ones, and you have every combination between 0, 0, 0, 0 and 1, 1, 1, 1. Then you have to fill out this one, and you have to fill out this one. So let's look at the booth. 0, 0, 0, 0. So if I zoom in here, let me zoom in and think that's going to help you guys. Okay, so the first one, 0, 0, 0, 0, that means there's nobody in any of the booths. So the light for the booth is on. Of course, there's going to be a place for somebody. Now, somebody steps into booth D. Is there still space to vote? Sure, somebody could be here, somebody could be here. So there's still room. So the light's on. It's saying, hey, come in, there's a booth available. What if somebody's here? Sure, there's plenty of room. There's only 1 person voting. What if 1, 1? There's a person voting in D, a person voting in C. Hey, the alarm should be on, right? All these, the alarm should be off, correct? 0, 0, 0, no alarm. Here, the alarm should be off. There's 2 people voting next to each other. So what's with the X? The X just means we don't care whether that's a 1 or a 0. That's all it means. Think about it. What would you put if I forced you? I said, hey, put a 1 or a 0 here. You'd be like, I don't know. I mean, I guess there's room here, but not really, because there's a person here. This person should get out and go over there. You know what I mean? Because the booth light shouldn't be on, put it that way. There's no way more than 2 people can vote, and there's 2 people, so I don't know. I don't care what that's doing. There's an alarm going off anyway at this point. The big red light is on, and who cares what the booth is doing at this point? So that's what the X is for. So on and forth. So I think you guys get how this is going. I'm not going to go over every combination. When you transfer this into a K-map, remember we learned K-maps, you're going to transfer it once. So all of the booth, all of these, remember you take these 4 and you put them here, and then you swap them, and so on and so forth until you fill this out. And if you'll circle these, because remember the X could be a 1 or a 0. You don't care what it is. So if a 1 works for you so you can circle 4 at a time, that's great. If you see an X over here and there's nothing nearby it, then don't circle it. But we'll pretend those are zeros. They can be whatever they want. We don't care what they are. So we're just going to ignore all these X's. And then, oh man, there's just that 1 X and the 1, 1 and a 1 down here. So, hey, I'll just pretend that one's a 1 and circle those. So pretty much it's this logic here, and circle these, and it's this logic here, and we write it here. Now, this one is for the alarm, and when we transfer all of these here into our K-map, using the rules where we swap the last ones and we swap these 2 rows, we can circle that chunk, we can circle this chunk, and we can circle this chunk, and it ends up being AB plus BC plus, I say plus, AB or BC or CD, okay? So that's it. That's going over that part. Then step 1, in your notebook, draw an AOI circuit for booth and for alarm. So draw draw this right here and draw this right here. Okay, so draw those two. Step 2, draw that again, but substituting the NANDs. Okay, so substituting the NANDs. And step 3, draw it in multi-sim, the NAND version. I think they want you to draw. If I read this, I think so. You can double check that. But I hope you guys get the idea. I'm going to do one more video where I'll do the booth one. I'll do the booth one, and I'll do the NAND one. If you want to do it, if you want to attempt it yourself, and you think I think I can do it, and then you can double check and watch this video and see if you did it right. So I'll do the booth one and the other booth one, the one where it's AOI and the one where it's NAND substitution, and see if you're right. And if you got that going, then I'm sure you can do the alarm by yourself. Okay. So that's it for now.